Okay, this video is aimed at Year 6 teachers who want to upskill themselves a little bit using CAD and kind of be a couple of steps ahead of the students they're going to be teaching. I tell you what, as a warning, I would say to you, right, just be prepared because you'll probably find yourself behind the students after a couple of lessons because they're going to assimilate these skills really, really quickly. It's a very user-friendly program, and students, once they've got past the basics, make rapid progress, okay? So just be prepared. They will be showing you things that they've discovered and how to do. So it's a pretty good picture, isn't it? Okay, let's have a look at what Tinkercad's all about. So you get a work plane here, which is like a build platform. I've left these wheels here to show you something on purpose. So this is the students' work from Year 7, and we do this rubber band racing car project. And in that, we have students who have to create wheels for a car powered by a band. And, you know, they've done some pretty complex stuff in here. Like they've understood the concept of concentricity, circumference and diameter. We go over with them, specific sort of constraints like the size of an axle and stuff like that. And they've done rotational patterns, and that's a lovely piece of CAD work there, right? So that's what they do with us in Year 7. So if they can do these fan designs with you in Year 6, then I love to think that they'd be able to be zooming ahead when they come into Year 7 with us next year. All right, so let's have a look. I've put the drawing plane back into perspective mode from what they call orthographic mode. You might prefer it in the flat mode. On the flat mode, look, you can look at it from the side, from the top, and things like that using the view cube, which you might find very useful. I don't know. Let's have a look, right? I sometimes quite like perspective. Anyway, let's have a look where we're going to get started. So we're going to try and design some devices that are going to be able to catch the wind. That's the whole idea, isn't it? So let's have a look. I'm going to bring in from my primitives menu. So this is what we call my primitives menu, right? I'm going to bring in something that I'm going to use as what we call a nacelle. So the spinning part or the center part of the wind turbine, okay? Now, anything that comes in when you drag it in comes in with a default size of 20 by 20 and 20 high. Now, you can change that if you want to. Just click in these numbers here. Let's make it by 30 by 30. There it is, look, 30 by 30. Okay, next job then, right? Okay, well, I'll tell you something clever you can do, I guess. Let's just zoom ahead a little bit. So where you're in your basic shapes, primitives, buttons, there are loads of shapes you can explore. So if you go from everyday objects down here, look, and have a search around, you will find a pencil, look. Now that pencil is a life-size pencil, right? And what I can do is I can use that pencil to create a hole. All I need to do is make sure that I put the pencil in let's switch back to 2D mode. I've got to make sure I put the pencil in the middle of the hole of the orange circle. So I'm just going to go to my align button over here, align, click on this orange bit, click there and click there, and that's put the pencil right in the middle of my orange nacelle bit. Okay. Now if I want to lift things up and down in Tinkercad, I've got to use this little black triangle at the top. Now I'd like to make that hole going through my nacelle. So what I'm going to do, I'm going to lasso everything and I'm going to group it. And what it'll do is it'll take away the pencil from the other shape and create a hole. So we've already learned quite a lot of basic stuff there, right? Importing things from the primitive menus and other menus as well. Like they might be messing around with paper cups and stuff like that for their device. These are paper cups. That's a full-size paper cup. You could use that if you wanted to. Let's go ahead and use it, shall we? Right, look, I'm going to bring that paper cup back in. Come on, paper cup, back in. There it is. Now, if I want to use that paper cup, but I want to spin it around, you've also got these drag handles that you can use, look, and you can spin things around. So there's a drag handle, and I could put that paper cup there, look, I could lower him down. I could make a copy of him with a copy and repeat button at the top. I can bring the copy and repeat one over here. I can use the flip button. I can flip that over, look, and I've got the basic starting point of a device. I'm going to get both of those pieces and I'm going to use my nudge arrows. That's the arrows on the keyboard. I'm going to move them over. Okay, let's go back into using a pencil again, right? If I bring that pencil, I grab that nudge button, pull him over 90 degrees. So you've got to be careful when you rotate stuff, right? Control Z and do. If I just pull that over 90 degrees, I should be able to somehow make that so it fits, I don't know, with just some glue or something, I guess, onto the top of that. So I bring that over so it's in line with the top, and then I drop that down. This could be a piece of wood. I don't know. If you've got access to a little drill, you could drill a hole in that. and then we could maybe use those pencils to fix these pieces in, duplicate and repeat, bring a copy of the pencil over this way, like that, maybe fitted side by side, maybe a cable tie or something like that. But you've already got there, like something which is going to catch the wind if you fix all that together, possibly. I don't know. That's the whole thing about it, isn't it? Experimenting and having a bit of fun. So let's have a look at making a custom made sort of fan though, right? Okay, so look what I'm going to do. I'm going to go back to my primitives button up here, basic shapes. And I'm going to use something like a cuboid there, like, right? So like I said, everything comes in 20 by 20 by 20. You can type numbers in, or you can just stretch stuff if you want to. Like now, what I'm doing on that one, like, is I'm squashing it and making it shorter. Right? If I want to make that into a propeller blade, all I've got to do is put a bit of a pitch on it, ideally 45 degrees, and that look is going to be able to catch the wind. Let's have a look what else I've got to do. I'm going to bring that in line with the center of the orange bit now. So you might have seen this before. If you lasso things and go to your align button, click the target, click that to align it. Now I'm going to grab that piece. I'm going to use my arrow on the keyboard and I'm going to push that into the shape. Next job, I'm going to duplicate and repeat, and I'm going to push the copy this way. And what I'd like to have is a bit of symmetry going on. So I'm going to click on top. I'm just going to eyeball it. So does it look the same? It looks very similar, yeah. Right, now for propeller, those two need to be facing the opposite direction. So what I'm going to do, I'm going to click on that one. I'm going to go to my flip button and I'm going to flip it that way. So for a propeller, that's looking a lot better. I mean, you could make that in a work in well with some simple tools. Like I use a broom handle dowel for that. Drill a hole. You can't drill a hexagonal hole, obviously, but you could drill a hole. Maybe hot glue, maybe blue tack will do the job, and then you could cut two slots and you could fix some cardboard in, couldn't you? If you students could do that, I reckon you could probably do that yourself for them. All right, but that would create you some kind of wind turbine. If you want more blades on it, let's have a look what we can do for more blades, right? Because it does get this is quite a useful feature. Click once, hold the shift button down to multi-select, click again. So you've got those two things selected. Duplicate and repeat. So you've made a copy of those two pieces and then drag with your drag handle around. Okay, I've gone 22.5 degrees around there. I think you saw that. Let's see what else I can do now. So all I got to do now is clicking, duplicate and repeat. And look what it does for me. It creates a turbine fan for me with flat blades, which is pretty clever, isn't it? That we could use for our job. We couldn't 3D print that, by the way, right? Because there's this gap on the base. If we wanted to 3D print that, we'd have to do some stuff like making the base bit shorter, so it's the same height as the blades, and then bringing the whole thing down. So grab everything, click to the right view there, I can just pull everything down to the work plane so it says 0. So we could 3D print that object, okay, probably without any supports or anything. So that'd be pretty cool. It's pretty massive though. So if you count, oops, daisy, control Z. If you count squares on that, like the build platform on my printer, I think it's about 22 centimeters. 1, 2, 4, 5, 6, 7, 8, 9, 10. Yeah, about 20 centimeters across. Okay, but you can make that smaller. You can grab the whole thing if you want to. You can group it, and then you can resize it. So let it all group up. Like, should all go one color once it's grouped. You can make it all one color if you want to. Now the problem will be if you resize this, look, then the hole in the center has been shrunken. It's now smaller than a pencil, but it's a bit of a better size to print out. You might find you've got students with 3D printers at home. They could be creating things like this if you want them to. They obviously like a good project. That sort of student who has access to that at home. So yeah, if you want to 3D print that object, you have to check a few things out. You know, if the print savvy ones know what I'm on about, it's got to be self-supporting. Otherwise, you've got to put a load of support in that's got to be broken off afterwards. It's got to be sat flat on the work plane as well. That's the thing. It's got to happen. Okay, next thing, if you want to 3D print it, right, select the thing you want to support to export. Click Export, click STL, and it'll download an XTL file for you, STL file, sorry, that you can import into your 3D printing software. And that's that. I think really it's just a case of getting started with it, and the more you do, the better you'll get. It randomly names objects as something, so you might want to just click on that and rename it. So test fan would be a good name for that, wouldn't it? I've got lots of test fans there. I think I'll probably call that one test fan 6, I think I'm on. And I've got a copy of that. All right, they are 10 minutes.